So we've learned many different ways how to integrate. Today we're going to look at some situations where we need to create new methods. So we're going to be using integration by parts. Say for example that we were asked to find, I'm going to ask you, can you integrate an integral of x e to the x dx? So do you know how to do that based on what skills you've learned? So as you look at this, you would say, okay, I'm going to try u substitution. The issue that we have is we're going to have leftover variables. There's almost like two functions within this integral. So we're going to talk about integration by parts. Let's quickly review how we would find the derivative using the product rule. If we had two functions u and v, we know that you could say it would be the derivative of u with respect to x times v plus u times the derivative of v with respect to x. Okay. If we were to then say, let's go ahead and integrate with respect to x, what we're going to end up with is uv equals the integral of v du plus the integral of u dv. Now we know that we're going to want to be having an integral sign by itself, or integral expression part by itself, so we're going to say what would happen if we were to get the integral of u dv by itself. Put this up here, so the integral of u dv, we could see that would equal, if you go back down to the expression we just looked at, it would be uv minus integral of v du. This is going to be key today, so if you wanted to put a box around it or some way to indicate that is the key idea for today. So let's look at a couple of examples. We'll go back to that first question I asked you. Could you integrate x e to the x? So what we're going to need to do is, you can see in this expression, we need to identify what u is and what dv is. U is always something that you want to be able to find the derivative of easily, while dv is something that you want to be able to find the integral of easily. So when we look over here, it's not necessarily that one is more easy to find the integral or derivative of. So I'm going to give you kind of some suggestions here of how to determine what u should be. Okay, so I'm going to use an acronym here. It's called LIPET, L-I-P-E-T. L stands for anything that is logarithmic. I stands for anything that is inverse trig. P is polynomial. E is anything exponential. And T is trig. You're going to end up seeing that sometimes the exponential and trig, the order can kind of flip-flop depending on what you want to do with it. So go back to our example. What would you think u would equal, and what do you think dv is going to equal? So you look at that list. Hopefully you put down that u is going to be x, and therefore dv is going to be e to the x. On the left-hand side, you are always finding the derivative, because we have what u is, we need to put down what du is. So du is going to be 1, the derivative of x is 1. We have dv, we need to find the integral, so the integral of e to the x is just e to the x. We could include plus c, but we're going to end up seeing that it's not important. If you were to go through and put it in, it's not going to be essential, because the plus c's are just going to combine, you're going to have a constant anyways. Okay, so if we look back at the formula that we put a box around, we can see that it's always uv, so I'm going to draw an arrow between u and v. It's always positive, okay, and then it's minus whatever we have for du times what v is. Okay, and we'll always use this kind of chart to keep our work organized. So go back to the problem that we were working on, and we're going to say this equals uv, so it's going to be x times e to the x minus the integral of 1 times e to the x dx. So this is going to equal x e to the x minus e to the x plus c. And if you want to do a quick check on this, we could just find the derivative of our answer to see if it gets us back to the original expression. So let's go and take the derivative with respect to x. X e to the x minus e to the x plus c. The derivative of x e to the x needs the product rule, so we're going to end up with e to the x plus x e to the x minus e to the x. The derivative of c is just 0, and you should see that we end up with the same expression as our original problem. Okay, so let's look at a couple other scenarios together as well. Number 2 is, let's say I was asking you to find the indefinite integral of x squared natural logarithm of x dx. Okay, so take a moment if you need to go back and look at kind of the order of operations and think about what u and dvu should be. Okay, hopefully for you picked that it was going to be ln natural logarithm of x. We don't know how to integrate natural logarithm of x, so it has to be u. Therefore, dv is going to be x squared. Derivative is the left-hand side. Derivative ln of x is 1 over x. The integral of x squared is 1/3 x cubed. So let's go ahead and rewrite this is going to be. So we know that it's u times v minus du and v. So this is going to equal 1/3 x cubed natural logarithm of x minus, I'm going to put 1/3 out front since it's just a coefficient. We have 1 over x cubed dx. Simplify what's within my integral a little bit, so I just have x squared. Okay, 1/3 times 1/3. I'm just going to erase this and change it to be 1/9. Okay, so there is my final answer. And if you wanted to check your work, you could take the derivative and make sure that you get the same thing. All right, look, another scenario here. What if I asked you to find the integral of x cubed e to the x squared dx? Okay, so again, you want to think about what should u and dv be. So when you look at your list, hopefully you say polynomial. It's going to come before anything exponential, so x cubed is u, and e to the x squared is dv. We take the derivative of u, we get 3x squared, and we come over here and we say, okay, we're going to have to use some u substitution, so that's going to be a bit more work involved, and I usually just recommend doing it off to the side. So u would have to equal x squared, du would have to equal 2x dx. Ooh, issue. We are missing an x next to e to the x squared. How could I resolve this? Well, I could go back to u and I could change this and just say, you know what, let's just make it x squared. I could change this and have x next to e to the x squared. That's still the same thing. I mean, it will change what du is. My derivative is going to change to 2x, but that should be able to work out now. I can find the, I'm going to also need to add 2 in here, so that means when I substitute, it would be 1/2 of e to the u du. Okay, therefore my integral is going to be 1/2 e to the x squared. If you want to do more work out on the side to verify that, that's fine as well. All right, let's go back to the integral here and use integration by parts. So we know that it's going to be uv, u times what v is, minus du times v. So let's see, we're going to have 1/2 x squared e to the x squared minus, coefficients are 2 and 1/2, so it just ends up being 1. The integral of x e to the x squared dx, that's actually the exact same problem that we were doing with dv. So I know that the u substitution is going to be very similar, but if you wanted to show it out again, you could say that u would be x squared, therefore du would be 2x dx. It'd be the integral of 1/2 e to the u du. Okay, so my answer that I'm going to end up getting, 1/2 x squared e to the x squared minus 1/2 e to the x squared plus c. If I wanted to factor out what's in common, I have 1/2 e to the x squared minus 1 plus c. This second answer that I'm putting a box around right now is probably more often how the textbook is going to show the answer. Try to get to that. If you got to this as well, that's okay. Last example. What if you were asked to find a definite interval, so let's say from 0 to 1, of arc sine of x dx. Just start by finding the indefinite integral, and then we can go from there. Now, it initially doesn't look like we're going to have to use integration by parts, but we don't know what the integral of arc sine x is. So I'm just going to add in a 1 being multiplied by 1, and therefore I can now set up what u and dv are going to be. U is going to be arc sine of x, dv will just make 1. The derivative of arc sine of x is 1 over the square root of 1 minus x squared. The integral of 1 would just be x. Set up our chart, so we have u times v minus du and v. Go ahead and integrate this now using integration by parts. So uv, so x, arc sine of x, minus the integral of x over the square root of 1 minus x squared dx, and then I'm going to use u substitution. I know that I'm going to end up letting u equal 1 minus x squared, therefore du would be negative 2x. Need to add in a negative 2, add in just plus, so 1/2 out front for it to be balanced, still equal the same thing. So now I can go ahead and integrate x arc sine x, and it's going to be plus the integral of 1 over u to the 1/2 du. Therefore, I need 1/2 out front still. Okay, so it's going to be x arc sine of x plus 1/2. Let's see, negative 1/2 add 1 is 1/2 now, but take the reciprocal, so 2 over 1. U was 1 minus x squared to the 1/2 plus c. So we have x arc sine of x plus 1 minus x squared to the 1/2 plus c, but we knew that we wanted to evaluating it at 0 and 1. So if I said x arc sine of x plus 1 minus x squared to the 1/2 power, we want to evaluate it in 0 and 1. If we work through that, you're going to end up getting pi over 2 minus 1. Alright, don't forget that day 1, the homework is going to be, so 8.2, day 1 homework is page 531. Numbers 1 through 10 all, and also numbers 12 through 36 every other even. If you have any questions, feel free to email me and I'll try to answer you that way.